Hey there, in this video we're going to make sense of a complex fraction, which is this complicated mess we've got right here. So what the heck does this even mean? Well, remember that a fraction is just another way of writing a division problem. So each of these fraction bars represents something that we're dividing. So another way that we can think of this is we're taking the rational expression we see on top here, and we are dividing it by the rational expression we see on the bottom here. So one way that we could rewrite this expression is with 8b over b plus 10 divided by 8b squared minus 56b all over b squared minus 12b plus 35. So that's what a complex fraction really means. It means that we're taking two fractions and dividing them. So now to continue this problem, we can use the techniques that we've learned for dividing fractions. To divide two fractions, we're going to use the fact that division is the inverse of multiplication. So if we want to treat this as a multiplication problem rather than a division problem, we need to take the inverse of this expression. And the way to invert a fraction is to take the reciprocal, meaning we're going to swap the numerator and denominator. So this will become b squared minus 12b plus 35 all over 8b squared minus 56b, and now we can multiply these two fractions together. So let's give ourselves a little bit more space to work on the next screen here. We've just inverted our rational expressions, so now we are ready to multiply. When we multiply fractions together, we know that we want to multiply the numerator times the numerator and the denominator times the denominator. But as these expressions are currently written, it's going to be a little bit more work than we need to do to multiply all of these terms together. To make our work easier for ourselves, we can see if there's anything that we can break apart into factors before we multiply across this problem. So let's look at each expression we have in our numerators and denominators and see if there's a simpler way that we can write these things. Looking at 8b, that is just a single term on its own, so there's no way that we can factor that apart. b plus 10 has more than one term, so it's possible we could try to factor that by looking for common factors or using one of our other factoring techniques, but b and 10 do not have any common factors, so we'll just leave those two expressions alone. We can, though, factor the expression we have in the numerator here. Since this is a trinomial, we can look for a pair of factors that will multiply to equal 35 and add to equal negative 12. If the number that we are trying to add to get is a negative number, but the number we're trying to multiply to get is a positive number, the only way that we could accomplish that is using a pair of negative numbers. Negative times a negative will become positive, and when we add two negative numbers, it will still be negative. And we can use negative 5 times negative 7 to solve this puzzle. So let's rewrite our numerator as b minus 5 times b minus 7. And now let's take a look at what we can do in this denominator. This is not a trinomial. We're not going to use the same trick we used in the numerator, but these two terms do have a common factor that we can factor out. 8 and 56 are both able to be divided by 8, so we can divide those terms by 8, and b and b squared contain a common factor of b. So we can factor out that 8b from both of those terms in the denominator, and that means that we're then going to divide each of those terms by 8b. 8b squared divided by 8b is going to be 1b, or just b by itself. 8 divided by 8 is 1, and b squared divided by b gives us b. When we divide negative 56b by 8b, these b's will cancel out. Anything divided by itself is 1, and negative 56 divided by 8 gives us negative 7. And now that we have factored everything, that's going to make this multiplication easier, because we know that we're allowed to divide common factors from the top and bottom of a fraction. If I have b minus 7 on the top and bottom of this fraction, I can divide those out, and we'll just be left with 1 from each of those factors. Eventually, all of these expressions are going to be put together into one fraction. So I can also start to divide terms from the numerator of this fraction with terms from the denominator of this fraction. And we have 8b matching on the numerator and denominator, so we can also cancel or divide those out, and we'll just be left with 1 from each of those factors. So now the simpler multiplication problem that we're doing is 1 over b plus 10 times b minus 5 over 1. And I guess I don't need parentheses anymore around this b minus 5 because there are no other factors in that numerator. When we multiply fractions, the method is to multiply the numerator times the numerator. 1 times b minus 5 is b minus 5. And multiply the denominator times the denominator. 1 times b plus 10 is b plus 10. So that is our final simplified answer. This answer cannot be simplified any further. There's a common mistake that I want you to watch out for. Sometimes it might be tempting to try to cancel out these b's that we see on the numerator and denominator to get an answer like this, negative 5 over 10. And that idea comes from a good place because you're thinking that we know we can divide common factors if we have something that's the same on the top and bottom of a fraction. But when we're dealing with more than one term, we have not just b, but b minus 5 together, and not just b in the denominator, but b plus 10 together. We are not able to cancel out just half of a factor with half of another factor. I think this is a little easier to see if we replace this variable with a number. Like imagine if we wrote the fraction 23 over 21. Well, we could try to separate this out as 20 plus 3 over 20 plus 1, but it would be silly to say, oh, well, now we can cancel out the 20s to get 3 over 1. Just from our understanding of numbers, we know that 23 divided by 21 is not the same thing as 3 because we're not able to separate that 20 from that 3. And that's sort of similar to what we have here with this b minus 5. We're not able to separate those two terms from each other if they're supposed to be subtracted together.